Let's talk about scientific notation. In particular, what we're going to do today is convert into standard notation and also convert into scientific notation. In other words, these are all in scientific notation. We're going to turn them into standard. These are in standard. We're going to turn them into scientific. All right, so let's dive in. First things first, let's check out these problems right here. Now, what we're going to do is we're going to start with this problem on the left. Let's zoom in a little bit and we'll get started. Well, the first thing we got to remember is this is in scientific notation. So right now, so scientific notation, we've got a factor in front with some sort of decimal. Notice there's only one digit to the left of the decimal. Now, technically what that means is that this first factor here is at least 1 but less than 10. But you know, for me, I find it easier just think about it this way. Just think of it as, look, there's a 1 digit to the left of the decimal point. Exactly 1, no less, no more, except it can't be a 0. Okay, so let's just figure out how we're going to convert this. Well, in standard notation, we're not going to have this extra factor of 10 to some power. So let's just write it out what that's going to be rather than as an exponent form, right? So this would be 2.8 times, I'm going to give myself some extra room, 10 squared, which is of course equal to 100. Right? And remember, whenever we've got a power of 10, in other words 10 to some exponent, the power is actually going to tell you how many zeros there are, right? 10 squared, 10 with 2 zeros, right? So that's just a handy little thing to remember. Okay, so really I like to have just a regular decimal here with no extra factors with tens. So what I'd really like to do is turn this 100 into a 1. If I can turn this 100 into a 1, that goes away. Well, let's just make it obvious that there's a decimal point here. We usually don't show a decimal, but let's do that just to know what's going to happen. So I'd like to bring this decimal over to the point where this is just a 1. Okay, so again, I'd like to bring it over 1. Now, bringing it over 1 is pretty easy with this factor on the left. Okay, so if this goes from 100 to 10, then this goes from 2.8 to 28. In other words, if you're bringing them each in 1, it's still the same value, right? This guy got bigger by 10, but this one got smaller by a factor of 10, okay? Well, great. So, hey, let's do that. I want to get to the point that this is 1. Okay, so let's move it again. So I keep moving my decimal, and finally, you know, I'm going to get to the point that this is times 1. That's my goal. But over here, unfortunately, I've kind of run out of decimal points here, right? Spots to do it. So let's think about this for a second. Is it 2.8 the same as 2.80? Right? It is, right? 2.8 is the same as 2.80. Hey, now I've got a place to move, okay? So I bring this guy over 1 more, and then sure enough, here's my decimal. So good, I moved it into, ready? 1, 2. Okay, now let's rewrite that. It's getting a little messy there. So this is like saying 280 times 1, isn't it? Right? Well, we wouldn't say 280 times 1. We're just going to write that as 280. All right, I converted from scientific notation to standard notation. All right, let's look at another one here. Okay, so for the next one, we got a similar sort of value, similar sort of look to it. And let's just try it again. Now, this time, what we're going to do here is just write it like we did before, right? I got 4.16 times, I'm just work this out, right? Times 10, right? Okay. Now we're not always going to write it this way, but just on the first one or two, right? So again, remember, this is like saying there's a decimal there. I want to move him over 1, then it would be times 1, wouldn't it? Well, that means I have to move this guy over 1, wouldn't I, right? So again, this would be like saying, and let's show more obviously where that new decimal point is, right? So my new decimal location is there, right? I'm counterbalancing effects, I was able to do that. So this is now 41.6 times 1, but of course we wouldn't write it like that. We're going to say 41.6. Okay? All right, so again, basically what we've seen here is the exponent on the 10 tells me how far I moved over my decimal point, right? In this case, it was 10 squared, so I moved it over twice. 1, 2. Again, let's look down here. We had more room. 1, 2. Okay, up here, 10 to the first, so I only had to move it over 1. Boom, like this. Okay? All right, let's now look at one where it gets much bigger. When it gets much bigger, you know, let's start to get a little more clever about this, right? I'm not going to always want to rate all these extra steps. I just want to do that the first time or two just to make it obvious what's happening. So really what we're saying is the exponent up here is 8, which means I have to move this decimal point over 8 spots. All right, well, let's figure out how we're going to do that. I've got 4.193. My first factor, that's what I start with, 4.193. I've got 3 spots already, right? I can go 1, 2, 3, so I can get closer, but you know, I'm going to need 5 more to get myself up to 8. So, you know, I'm just going to write some more zeros here, right? I've got 3 already, so I need 5 more zeros, right? Okay, 1, 2, 3, 4, 5. Okay, that's going to give me enough spots, right, to compensate for this 8 here, right? So let's convert this, right? So I go 1, 2, 3, 4, 5, 6, 7, 8. My new decimal location's over here. So this number right here is the same as that. Now, again, I want to rewrite it. This is messy. You should never finish an answer looking like this with all the squiggles under it. So let's rewrite it. 4193, and again, there's 5 zeros. 1, 2, 3, 4, 5. Okay. Really big number, kind of messy if we don't put some commas in there. So let's put some 1, 2, 3, 1, 2, 3. Okay, that's a little more obvious. This is 419,300,000. Okay, all right, which kind of makes sense because 10 to the 9th is a billion. Okay, 10 to the 9th, and this is a little bit less than a billion, which is, you know, as far as big numbers go, that makes sense. Okay, so that's what happens when we convert into standard notation, right? So what we've done here is we've converted numbers into standard notation. All right, let's now take the next step where we're going to convert rather into standard notation, right? Rather into standard, we're going to convert from standard to scientific. Okay, so here's our next set of problems. This time, we're going to convert these into scientific notation, okay? So let's do these. Zoom in and begin with this guy right here. Okay, so I've got 510,000. Okay, so what we can think of is, again, it's like you've got a decimal point right here. I mean, you could write it like that. We normally don't, but it's just like we had one. So let me rewrite this though, because it's actually usually easier to do these when you don't have the commas, because that can throw us off a little bit. So I'm going to rewrite this without the commas just for my conversion. So I've got 5, 1, 0, right? Look how many zeros I had. I had 4 zeros. Okay, and again, it's like I've got a decimal point there that's just sort of hidden. You know, we just kind of know it's there. Okay, so I want to get this decimal over here. Remember, in scientific notation, your first factor has 1 digit that's not 0, and then everything else comes after the decimal point. Okay, so let's bring it around. And sometimes it's just that. I mean, this could have been 500,000, in which case there'd been nothing after the digit. Okay, so let's just count them over. Ready? Okay, I go 1, 2, 3, 4, 5. Okay, that's what it's going to look like. But I moved it over 5, so to compensate for that, so that it's still the same value, I've got times 10 to the 5th, right? I moved it over this over 5, made it, 5, factors of 10. So this has to be times 10 to the 5th. And again, now let's rewrite it so it's neat and tidy. I've got 5.1 times 10 to the 5th. Okay. Well, speaking of neat and tidy, I'm kind of doing this at angles, so my lines aren't ideal. But I did want to just take a second. Look at the size of my multiplication symbol. Notice that it's definitely smaller than this other stuff here. So doing it well, you're gonna have an x that you can tell it's an x. But it's not as big as the other values. It's not like, an x that's a variable. It's a little bit, it's in the middle. Notice it's centered. It's definitely smaller, but it's not so small either. I mean, just again, don't be tempted to do it like this. It's not like this. You wouldn't write this as 5.1 dot 10 to the 5th. Now, I know you might say, but come on, that's technically correct. It is, but that's just not the way it's done. It's just not the style that people use. So don't do it like this, okay? I'm just showing you how not to do it. It's in scientific notation, we always use the x. Okay, so let's move on to the next one. All right, so we just did that first one. Let's look now at 347. How would we convert 347? Okay, 347 means, right, 347. Just going to rewrite it so we got some room. Remember that it's like there's a decimal point right there. So the decimal point right there. So I want to get that decimal point over here. I want it to be 3.47 times something, right? So boom, boom. I want my decimal point right there. Well, let's see. I moved it over 2 spots. So this is times 10 to the 2nd power. Again, let's write that better, a little neater. 3.47 times 10 to the 2. Okay, there we go. All right, finally, what happens when it's a number smaller than 1, right? We got a number smaller than 1 this time. So this time I want to bring my decimal point the other direction, don't I? Right? I don't really want it to be over here. I want 7 to be the leading digit, not a bunch of zeros. So I'm going to rewrite that again as 0.078. Okay? All right, my decimal point's there. Now, okay, great. Well, I really want to bring my decimal point the other direction this time, to the right. Right? So now it's going to look like this. I want it to be 7.8. And well, look what here. Here I moved it 2 digits to the left, and I had to compensate by making it 10 to the 2. Well, then I guess we'll make it the other direction. Rather than positive, let's call this a negative 2, right? So, if you make the first factor smaller, that means then your second factor, the one with the tens, has to get bigger. Well, same thing here. Here, I'm making my first factor bigger, so then this has to compensate by being smaller. Okay, and so sure enough, this would be 7.8 times 10 to the negative 2. Okay, all right, so that's what we do when we're working with going into scientific notation, right? Scientific, you're counting how far you would move your decimal point, either to the left, which means that you have to compensate by having it bigger, or to the right, which means you're making it smaller. Okay, so finally, let's come back. Let's do a few where we'll go the other way. So we're going back to these first ones. Remember, we did these. We're turning it into standard. Well, okay, so let's just do a quick couple examples here where I'll just leave it there so we can see them all. Where we're going the other direction, and again, this is times 10 to the negative 3. Times 10 to the negative 3. Okay, so again, I'm going to zoom in so we can see that a little better. And here we go. So 1.7 times 10 to the negative 3. This time what I'm trying to do is I have to take into account the fact that this is 10 to the negative 3. Well, okay, so before, right, that meant times 10 to the positive. If it was a positive exponent, that means it's getting bigger. Here I'm making it smaller. So let's write the 1.7. I've got 1.7, okay? It's smaller than this actually though, so I'm going to be moving my decimal point the other direction. Well, I can move it 1 real easy, right? Boom, there I go. But that's not enough, is it? I need to do that 2 more times. So, well, let's think about this. 1.7, I could write 1.7 with a couple zeros in front, couldn't I? Right? I mean, we wouldn't normally do that, but that's still correct, right? So it turns out that's how we're going to use it. So I'm going to move it over. So I brought over 1, I brought it over 2, I brought it over 3 times. Okay, brought it over 3 times. So that is now what that number is. Okay, I'm going to rewrite it and kind of center it a little better so it's a little easier to read. I've got decimal point 0.0017. Okay, technically that's the right answer. Stylistically though, we usually want to put a 0 in front. And for a couple of reasons, it just sort of makes it more obvious that there's a digit there. Again, it's just kind of the style. We generally, when we write decimals, we want something to the left of the decimal point. Technically, you don't have to, but it just kind of looks weird and kind of confuses people if you don't. So this is what we need. Now, what's kind of interesting is what happened here. Notice this is 10 to the minus 3. Well, what you see is there's 2 zeros here, and then you sort of have this extra one. So, I mean, if you want just sort of a shortcut, double check, 10 to the minus 3, you do end up with 3 zeros, but remember one of those zeros is the one in front of the decimal point. All right, finally, let's do the same thing with this number right here. I've got 2.63 times 10 to the negative 5th. Now, I'm going to give myself a little more room to work here because I'm going to be pushing it over a lot. So I've got 2.63. I'm going to need a whole bunch of zeros here. All right, so let me just give myself some zeros. I'm going to need a grand total of 5 zeros. Remember, 5 zeros. So I've got 1, 2, 3, 4, 5. Right? I'm going to need 5 zeros. Again, this is still true. It looks a little funny, but that's still the correct number. So I'm going to move this over 5 times. Ready? Okay, 1, 2, 3, 4, and 5. Okay, 5 times. 0.000, 4 zeros. So I get to rewrite this as 0.1234263. Okay, and there's my answer. Okay, so quick review. Remember, when we're converting into standard from scientific, the exponent on the 10 tells you whether it's getting bigger or smaller, right? These are bigger, so you move to the right. When it's a negative, they're smaller, so I had to move the decimal to the left. When I'm converting to scientific notation, now we have to count how far we're moving it over, right? In this case, 1, 2, 3, 4, 5, right? So times 10 to the 5th. 2, if you go the other way, if it's less than 1, it's going to be a negative. All right, well, thanks for joining us today, and have an awesome one.